All right, we're going to go over the 1.6, 1.9 review today. The first 6 questions here are asking you to name the parent function. You have to be familiar enough with these parent functions to get them right. The board will be covered up, so you won't be able to see these parent functions behind you while you quiz. So, looking at this first one, you have to understand that typically when we have this vertical asymptote and then a horizontal one, and then you got like a pair of corners somewhere in there, that's going to be our 1 over x function there. So you can just write the equation. You don't have to know that, hey, that's rational function or the inverse function or anything like that. This one right here is going to be x cubed. It has this type of pattern going on to it. Now, this isn't the graph of x cubed, but it's the parent function to this transformation is x cubed. Same thing for this one. This one's going to be x squared. Once again, it's not, when I mean same thing, I'm saying it's not the graph of x squared. It's the graph of like x squared shifted over and then down, but the parent function is x squared. This one's square root of x. This one is going to be the absolute value of x. And then this one again is going to be x cubed. Notice it has that same type of pattern to it right there. Over here we're going to graph these parent functions and then we're going to translate them. So the graph of absolute value of x looks something like this. But this is saying shift it to the left 2. So we're going to take that vertex and shift everything over 1, 2. Like that. And so there it is, shift it to the left 2. That plus 2 means send it kind of the opposite direction that we're thinking, to the left, when it's grouped with the x. This one we have to be able to recognize that the parent function here is going to be x squared. And then so our x squared comes through kind of like this. I'm not going to graph it real exact because I'm getting ready to move it around. Actually, let me do that. Let me graph it exact, and then I can just kind of pick it up and move it. So we know that x squared looks like this right here. 1 squared is 1, 2 squared is 4, 1, 2, 3, 4. 3 squared is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to mirror this here. And so as I shift this around, I want to shift it, notice down 5, that's on the outside there, so it means shift it down 5. There's 1, 2, 3, 4, 5. One more. And then I'm going to shift it to the left 3. So shifting it to the left 3, there's 1, 2, 3 right there. So you kind of see what the original function looked like, and then with the transformations, it's right here. Now, since you can't just pick it up and shift it around like I just did, what I would do is shift the vertex and then just kind of pretend like that's the origin. Go over 1, up 1, put a dot, over 2, up 4, put a dot, and then over 3, up 9, put a dot. And then you can kind of just, recognize that, hey, we got a new axis of symmetry, and since it's symmetrical, you can go over 3 this way, 3 that way, and they match up. So that's how I would do it if you can't actually do it digitally like I did, where you just pick it up and move it. Now, for 1 over x, that's our parent function right here. Notice the parent function is being shifted up 1, and then to the left 4 there. So normally with 1 over x, you got to understand that we have a horizontal asymptote here, a vertical asymptote right here. And you can put in values if you forget, like at x equals 1, we have 1 over 1, which equals 1. At x equals negative 1, it becomes negative 1. So we've got this point right here. And so that kind of tells you the corners, or the quadrants your corners are going to be in. So know that's going to be really close to the x-axis, and then it's going to get really close to the y-axis like this. And same thing right here. So graphing your parent function first will help, and then we can shift this thing around. So I know it goes up 1. Everything gets moved up 1 space. Well, the vertical line being shifted up 1 doesn't really change anything, but my asymptote gets shifted up 1. So does the rest of these points in here. That little point won't highlight, he gets shifted up 1. And then so does this corner, gets shifted up 1 too. And then I know it gets shifted to the left 4. So I'm going to move this over to the left 4. There's 1, 2, 3, 4. This gets moved over 1, 2, 3, 4. It's a vertical asymptote, 1, 2, 3, 4. Just a little bit further over like that. Or just a little bit more. There we go. And then this corner gets moved over 4 as well. So this dot got moved up 1, and it goes over 1, 2, 3, 4 like this. So how I would graph this, if you can't just shift things around, is I would first shift around the asymptotes, and then just say 1, 1, put a dot, negative 1, 1, put a dot, and then you can make your corners in there. So these, it says if the f of x is x plus 5 and the g of x is x squared plus 3x minus 10, find and state the domain for each. So as we put these in here, let's see what we get. So we want the f plus g of x. Notice that this one currently is all reals, negative infinity to infinity. So is this one right here. Adding these two functions, I get x plus 5 plus x squared plus 3x minus 10. And I'm going to combine my like terms in here. I've got an x and a 3x. That gives me 4 x's. X squared goes right here. It doesn't have anybody to pair with. 5 minus 10 is minus 5. And this doesn't have any radicals in it, so I don't have to worry about even roots. It doesn't have a fraction. The domain for this thing is going to be all reals. So it goes from negative infinity to positive infinity. F minus g of x, well, I'm going to put in the f function. That's x plus 5. And then minus this whole function right here. I put it in parentheses because I got to minus each term here. So basically I'm going to distribute that negative. So that gives me x plus 5 minus x squared minus 3x plus 10, because I'm distributing that negative to each term. And then I'm going to combine my like terms. So x minus 3x is negative 2x's. The negative x squared just goes out front. And then 5 plus 10 gives me plus 15. So this is my answer to the number 11 here. Once again, no square roots, and then there's no fractions, so my domain is going to be all reals. For the f times g of x, I'll change color so we can see it a little bit better and kind of distinguish it from what I've written in blue so far. I'm going to write out the f function, and I'm going to multiply it times x squared plus 3x minus 10. And I'm just going to distribute each one of these. So x times x squared is x cubed. X times 3x is 3x squared. X times negative 10 is negative 10x. 5 times x squared is 5x squared. 5 times 3x is 15x. 5 times negative 10 is negative 50. And then combining my like terms, I get x cubed plus 3x and 5x give me 8x's. This is 8x squared actually. Negative 10x plus 15x gives me 5x. And then I just got negative 50 right here. Once again, no square roots, no fractions. The domain is going to be all reals. I'm going to erase this because it's getting kind of crowded here to do the last problem here. So I've got f over g of x. So I'm going to take the f function, write it out, x plus 5 over x squared plus 3x minus 10. And for this, for the domain, if I left it like this and said, okay, there it is, I divided it out, I still need to know what the domain is. I need to know, since it's a fraction, what values of x will make the bottom 0. So here's a case where we're going to have to factor. So I want factors of negative 10 that will add up to the middle term 3. So like 2 and 5, 2 times 5 is positive 10. I need it to add up or multiply to give me negative 10. So I'm going to make the 2 negative. Multiplying the 2 gives me negative 10. Adding it gives me positive 3. So I can, since the leading coefficient here is 1, I can say there's a shortcut, and that's just that this will factor to x minus 2 times x plus 5. Now notice our x plus 5s will cancel out here, and I get this function simplifies to 1 over x minus 2. However, for my domain, I have to take into account that if x is negative 5, it still makes this thing 0. So just because it cancels doesn't mean that doesn't affect the domain. So my domain, I've got to know, when does this equal 0? Well, x minus 2 equals 0 when x equals 2, and x plus 5 equals 0 when x equals negative 5. So I can't have x being negative 5, I can't have x equaling 2. So I need to exclude that from my domain. What that means, if negative 5 is right here and positive 2 is right here, I can have all of these values for x except for negative 5, all of these values of x except for 2, and then on to infinity there. So to write this out, my function becomes 1 over x minus 2, and the domain starts at negative infinity. It goes all the way up to negative 5, don't include the negative 5. Pick back up at negative 5, not including it. Go all the way to 2, exclude the 2, and then go to infinity. So here we want to find the composite of each function. So it says, given that the f of x is negative 9x plus 3 and g of x is x to the 4th, find the f of g of x. So when we find the f of g of x, what we're wanting to do here is we want to write out the f function, and everywhere I see this x, I'm going to put a set of parentheses. So I have negative 9 parentheses x plus, plus 3. So notice it's the same thing as like negative 9x plus 3, except for instead of an x, I have a parentheses there. Because inside that parentheses goes the g function. So I'm going to put that g function in where the x goes, and the g function is x to the 4th. And then simplifying this, this becomes 9x to the 4th, or negative 9x to the 4th, plus 3. And that's where this one right here ends. For the next one, I want to know what the f of g of x is again. But my f function for number 15 is going to be x squared plus 7. So I set it out as parentheses, squared plus 7. Where there was an x here, I've made it just parentheses because I'm going to put something in for the x. And what I'm putting in for the x is the g function, which is x minus 3. And so from here I'm going to square that binomial. You can write it out like x minus 3 times x minus 3 and FOIL it. But if you know the shortcut for a binomial squared, it's a lot faster. Square the x, square the 3, multiply the 2, so that's negative 3 times x, and double it. So I get negative 6x. And then bring down that plus 7. Now we're just going to combine our like terms. 9 and 7 give me 16. And so you get x squared minus 6x plus 16 as your answer for number 15. Number 16, I'm going to do over here on the left. So number 16, we want to find, notice they switched it around on us, the g of f of x. Not the f of g of x, it's the g of f of x. So this time I'm going to write out the g function first, and wherever I see an x, I'm going to put a set of parentheses in for it. And then I'm going to put the f function into it. So 4x plus 3. Now from here, I can actually do the binomial shortcut again. Square the first term, that's 16x squared. Square the last term, that's plus 9. Multiply the two together, that gives me 3 times 4x, which is 12x, and double it. So I got 24x's there. And that's as far as I can take that one right there. For number 17, I'm going to clear out some of this stuff. So for number 17 here, I'm going to say I want to once again find the g of f of x. So write out the g function, and wherever you see an x, put a set of parentheses there. So I've got parentheses squared plus 2 times parentheses minus 8. And now I'm going to put the f function into where the x was in the g function. So the f of x is x minus 1. Put that in here. And then from there, I'm just going to simplify it. So once again, we got a binomial square. So we're going to take the shortcut here, square the first term, square the last term, multiply the two together, you get negative 1 times x is negative 1x, and double it, you get negative 2x's. Distribute this 2 over here, and bring down that negative 8. And from here, it's just combining like terms. So I don't have any other x squareds. Negative 2x and 2x, they cancel. 1 minus 2 is negative 1. Negative 1 minus 8 is negative 9. So that's where we're going to finish that one. This one right here, we want to verify if they're inverses. We're going to do it algebraically, and then we're going to do it graphically here. So to do it algebraically, and this gives you a big hint here, use composite functions. I'm going to take first the f of g of x. Now if they're inverses, then this should just come out to be x. So I'm going to write out my f function, and wherever I see an x, I put a set of parentheses. And then I'm going to substitute the g function in for that set of parentheses there. So the square root of x plus 5 right here. The square root and the square will cancel each other out, and I get x plus 5 minus 5. 5 minus 5 is 0, so I get x. So since the f of g of x is equal to x, I know that f and g are inverses to one another. You could have also have written this out as the g of f of x, and it should also give you x as an answer if they're inverses to one another. So if I try that out, you don't have to do both on the quiz, but I'll take either one. I'm going to write out the g function, and everywhere I see an x, I'm going to put a set of parentheses in. And then I'm going to substitute the f function into it. So x squared minus 5 goes right here. Now this parentheses isn't helping me out anymore. I can just write it like this, x squared minus 5 plus 5, and we're square rooting it. Minus 5 and plus 5 go to 0. So I just get the square root of x squared, which equals x. So once again, it's another way to show that those are inverses to one another. Now we learn that graphically, a function is an inverse if it is reflective over the line y equals x. So we should see if we graph these, there should be reflection over y equals x. And so I'm going to graph x squared minus 5. So remember, minus 5, it's the parent function of the parabola here. And we're going to shift it down 5. So I'm going to go down 1, 2, 3, 4, 5. And I'm just going to pretend like that's the origin. Go over 1, up 1. Go over 2, up 4. And then go over 3, up 9. Notice the restriction on the x inputs there. It's for when it's greater than or equal to 0. So I'm only graphing this side of the function. I'm not graphing the left side. And there's a reason for that. If we look at x squared, the square root of x plus 5, that means shift this to the left 5. And then we know that the original square root of x goes through like this, but I'm going to shift it to the left 5. 1, 2, 3, 4, 5. I'm going to change color too. 1, 2, 3, 4, 5. Right there is where it starts. And we're going to pretend like that's the origin. I would say the square root of 0 is 0. Square root of 1 is 1. The square root of 4 is 2. The square root of 9, 0, 5, 6, 7, 8, 9 is 3. So it's going to go through like this. That's just shifting over the square root of x to the left 5. And I just pretend like it was the origin to come up with those points to plot there. And now if we look along the line y equals x, you can kind of see how if this is a piece of paper and I folded it, this part would land up on this part, this right here would land on this part right here. So they're inverses. We can show that graphically there. So this one wants us to find the inverses. Remember our procedure for finding inverses. We're going to replace this with a y and then switch y and x. So when I switch them, I get x equals y cubed minus 6. Now I'll get y by itself. To get y by itself, I add 6 and then take the cubic root. I'm going to write this up top now. So taking the cubic root of both sides gives me cubic root of x plus 6 is equal to y. So here's your inverse. And we can replace this now with the functional notation f of x, and we'll do that little inverse symbol right there to show it's the inverse of f of x. Same thing for this one right here. We're going to replace this with y, and then we're going to switch the x and the y and solve for y. Add 5 to both sides. You get x plus 5 equals y plus 7 quantity squared. Square root both sides. I'm going to continue on the right here. So square rooting both sides to get the square root of x plus 5 is equal to y plus 7. Subtract 7 and you get the square root of x plus 5 minus 7 is equal to y. So for this one, it says consider the following table, find the f of 0. So remember that this right here, this top row is my x inputs. The next row is the f of x. The next row after that is the g of x. In algebra class, you learn this as like, if we ignored this row right here, we'd say here's a table with x and y values. X is negative 5, y is 7. X is negative 2, y is 0. But if we left it as y and y, we get confused of what function we were talking about if we wrote it as two y values here. So we're dealing with two different functions. This is the f function, and the f of x is the y value when you put x into that thing. Same thing for the g function here. It's a different function. When I put in that x value, it gets me a y value on the g function. So looking at this, when what is the f of 0? When I input 0 into the f function, I get 1 as my output. When I put 7 into the g function, I get 0 as my output. When I put, and this one's the combination here, I first want to figure out what is the g of 0. So when I put 0 into the g function, it outputs a 7. So this blue box right here is the same thing as 7. So f of g of 0 is the same thing as taking the f of 7, because the g of 0 is the same thing as 7. So now I can go back and say, well, when I'm at 7, in the f function, out comes a negative 2. So all in all, if you want to write it out like this, it's fine. You can say the f of g of 0 is equal to negative 2. Next, we have the the g of f of negative 5. First, figure out what is the f of negative 5. So when I put negative 5 into the f function, out comes a 7. So this is the same thing as taking the g of 7. When I put 7 into the g function, out comes a 0. So this is going to spit out a 0. So this is the same thing as saying the g of f of negative 5 is 0. Now this graph is the same thing as we saw on the chart. The only difference is we're not looking at a chart, we're looking at a graph. So when I look at this part on the top right here, I want to know first, what is the g of 0? So when I put 0, when the x value is 0, what is the y or the g of 0, or the y value of the g function there at 0? And so it's spitting out a 2. So this blue box right here is equal to 2. So the g of 0 is the same thing as 2, so the f of g of 0 is the same thing as saying the f of 2. When I go to the 2 on the x value, I want to go up to the f function, which is up top, and that's going to output a 5 right there. So the f of 2 is equal to 5. Next, the f of -4. The f of -4, well, right here's the -4 on the x-axis. The f function is displaying the point -4, 2. So this is equal to 2. So this is like taking the g of 2. Since the f of -4 equals 2, taking the g of that mess is the same thing as taking the g of 2. So go to 2, and on the g function you got a point here at 2, 1. So the g of 2 is equal to 1. Next, find the g of 3. So go to the 3, and on the g function you have -2. So this is equal to -2. So the f of -2, go to -2, and the f function there is outputting a 3. So the f of g of 3 is equal to 3. And then lastly here we have the f of -3. So first find out what the f of -3 is. At -3 you have 1, 2, and about a half there. So this is the same thing as about 2.5. So I want to know what is the f of 2.5. Go to 2.5. And then go up 1, 2, 3, 4. Looks like it's going to be 4 on the f function there. So we can say that whole thing is equal to 4 right there. Alright, in these last few here, this says if the f of g of x is the cubic root of x plus 2, then find the f of x and find the g of x. It's helpful if we can start to recognize parent functions here. Like I'm noticing that this is a cubic root function right here. So the cubic root of x is what I believe this is just testing it out, the f of x is. And then what I'm putting in for x is going to be x plus 2. And we can check this by saying if we had the f of g of x here, and then this is true, then I'm going to put a parentheses wherever I see the x, and then I'm going to substitute the x plus 2 in for it, because I'm putting in the g function right here. And that should give me what I originally had here, and it does. So that's a good sign there. Next one. This is going to be, I'm going to look at it as 1 over x, because I see that fraction there. And what can I put in for x to make it look like this? Well, the g function could be 2x. Once again, you can test that out. If I were taking the f of g of x, and if the f of x is 1 over x, I put 1 over parentheses, and then I would substitute in the g function there, 2x. And that matches up with what's given over here. For number 32, we've got let's make the base 5, and it's going to be an exponential 5 to x, 5 to the x, and then x plus 2 is this right here. So if I have the f of g of x, then I'm going to say 5 raised to the parentheses, and put x plus 2 into it up there. And that should match up. Now for this one over here, we've got if the f of x is x squared plus 9, then find all of this mess right here. So I'm going to start with this function. It's the f function. I'm going to write out the f function as it's defined right there. So that's going to be parentheses squared plus 9. And I'm going to substitute x plus h in there for it. Bring over my minus sign there. And I'm going to subtract the whole f of x. The whole f of x is x squared plus 9. And put that all over h. Now I don't expect you to do much more than this, but we can clean it up a little bit. By the way, this x squared plus 9 should be in parentheses. Distribute your negative. And so we're going to end and do the shortcut to that binomial squared there. I'm going to distribute this negative right here. Put it all over h. And that's going to let me cancel out some things like x squared and minus x squared, positive 9 and minus 9. And I end up with 2xh plus h squared all over h. We can even factor out an h here. I get 2x plus h, and we can actually cancel out the h's here. and it simplifies all the way down to 2x plus h. I really don't expect you to go much further than this, though, for most of these types of problems. You can stop right there so you don't make any mistakes simplifying it. I just want to see, can you correctly substitute it in those spots for that difference quotient there. All right. Hope this helped. Let me know if you have any questions before the quiz.